Hello everyone, welcome to the NPTEL online course on electric vehicles. In our previous interaction, we have covered the topic benefits of using EVs compared to other modes of transport. Now, let us discuss the next topic, which is overview of types of EVs and their challenges. So, EVs can be classified in various ways. It can be classified in terms of proportional devices or energy sources or even the energy carriers which are used as medium to transfer energy from energy sources to propulsion devices. So, based on propulsion systems, EVs can be classified as pure electric vehicle or hybrid electric vehicle. A pure electric vehicle uses electric motor as a sole device for propulsion, while an HEV uses both electric motor and IC engine for propulsion. Popularly, pure electric vehicles are also known as EVs, while HEVs are known as HVs. If we classify the EVs on the basis of energy sources, pure electric vehicle will be further classified into battery electric vehicle and fuel cell electric vehicle. So, an HEV uses both liquid fuel and battery as energy source, while a battery electric vehicle uses battery as a sole energy source. On the other hand, a fuel cell electric vehicle uses both battery and fuel cell as energy sources. A similar classification can be done on the basis of energy carriers, where the energy carrier for battery is electricity, while the energy carrier for a fuel cell is hydrogen. So, 4 types of EVs comes under the family of pure electric vehicle. They are battery electric vehicle, fuel cell electric vehicle, ultra capacitor electric vehicle and ultra flywheel electric vehicle. In all these vehicles, the battery is a common energy source. While a BEV uses battery as a sole energy source, fuel cell electric vehicle, ultra capacitor electric vehicle and ultra flywheel electric vehicle uses battery as a hybrid energy source. In a fuel cell electric vehicle, battery is primarily used for absorbing the regenerative power, since fuel cell is incapable of storing the renewable energy. While in ultra capacitor and ultra flywheel based EVs, batteries are required for storing energy, since ultra capacitor and ultra flywheel have very low specific energy. So, as we know, a hybrid electric vehicle uses both motor and IC engine for propulsion. So, on the basis of the ratio of hybridization between electric motor and IC engine, it is classified into 5 types: micro hybrid, mild hybrid, full hybrid, plug-in hybrid and range extended hybrid electric vehicle. So, the rating of electric motor is very low in micro hybrid vehicle and is high in REVs. On the other hand, the rating of IC engine is high in a micro hybrid, while it is low in a REV. So, micro hybrid, mild hybrid and full hybrid are clubbed and known as conventional hybrid electric vehicle, while plug-in hybrid or PHEVs and range extended hybrid, which is known as REV, are clubbed under gradable HEVs. So, the difference between these two types is that the conventional HEVs can be refueled only at the filling stations or petrol bunks, while a gradable HEVs can be refueled both electrically and at the filling stations. So, a gradable HEV enables direct charging of battery using charging ports in addition to refueling by liquid fuels at a filling station. So, the classification of all types of electric vehicles in terms of propulsion devices, energy carriers and energy sources is elaborated here. So, in terms of propulsion systems, a hybrid electric vehicle primarily use an engine and electric motor, while a pure electric vehicle uses solely electric motor for propulsion. On the other hand, if we classify the EVs on the base of energy carriers, hybrid vehicles uses either liquid fuels or electricity as energy carriers, while a pure electric vehicle uses either battery or hydrogen as energy carriers. If we classify the EVs on the basis of energy sources, we will see that hybrid vehicles uses either liquid fuels or battery as energy source, while a pure EV uses battery and other types of energy sources as ultracapacitor, ultrafly and fuel cell as energy sources. The vehicle configuration of a typical battery electric vehicle is elaborated here. So, we can see that the battery bank in a BEV is normally charged directly from the grid using a battery charger, and the electrical energy stored in the battery is transferred to the wheels using a electric drive consisting of a power converter and an electrical machine via transmission gears and differential. This power converter has to be designed to carry bidirectional power flow, since it can also be used to regenerate the power coming from the wheels during braking. You can also see that the clutch is normally not required in a battery electric vehicle as in conventional IC engine based vehicle. This is the configuration of a typical fuel cell electric vehicle. So, it uses fuel cell as a source of energy, which is connected to hydrogen tank. A boost converter is required to step up the voltage of the fuel cell to charge the battery and store the energy. And the electric drive and the mechanical propulsion system is similar to battery electric vehicle. Battery bank enables two purposes. First, it allows fuel cell to operate at optimum efficiency. Secondly, it can support the transient mechanical energy requirements of the wheels. It can also help to store the regenerative energy coming during braking, since fuel cell is incapable of storing the regenerative energy. As we all know, an IC engine requires a starter motor for starting an IC engine and an alternator to recharge the battery once the IC engine had started functioning. So, these two functions can be kept together in a device called integrated starter generator, or ISG in short form. So, an ISG is an electrical machine which can be connected to the IC engine either using a belt driven system, or it can be directly mounted to the crankshaft. So, what is the role of an ISG? So, it can assist the IC engine in various ways. So, among the different types of conventional HEVs, the micro hybrid, mild hybrid and full hybrid provides and offers different types of capabilities to the system. In a micro hybrid, an ISG of around 3 to 5 kilowatt with a system voltage of 14 to 42 volts is used. So, the ISG supports not only the starting of the IC engine, it can also support the stopping of IC engine when the vehicle is at rest. So, this is known as start stop feature. So, this feature will enable fuel economy in these vehicles. ISG can also help in recovery of regenerative power available during braking. Generally, this is a low power ISG and they are connected using belt driven systems. In a mild hybrid, an ISG of slightly higher rating is used, typically 7 to 15 kilowatts with a system voltage of 100 to 150 volts. So, this ISG enables not only start stop feature and regenerative braking, but it can also support the IC engine in power sharing during normal operation, which means the IC engine rating can be reduced to a little extent. In a mild hybrid, the ISG cannot support a pure electric motor based launching or starting of the vehicle. Differing from the operations of micro and mild hybrids, a full hybrid offers more versatile operation. The vehicle can operate in IC engine mode alone, an electric motor alone, or a combination of both the IC engine and motor together. It requires a complicated transmission system which is known as electronic variable transmission, which is generally a high power device of 50 to 60 kilowatt with a system voltage of 500 to 600 volts. So, this device allows connection of IC engine and motor together or in a sole way to the wheels, and that allows various kind of operations possible, such as start stop, regenerative braking, power assist, and also electrical launch. Means a full hybrid can start in all electric mode using an electric motor alone. Since full hybrid can work in various modes, the IC engine can now operate in high efficiency mode in optimum operation line, which is a known as OOL in IC engine terminology. So, among gradable HEVs, the PHEV or plug-in hybrid vehicle is derived from the configuration of full hybrid. So, this system mostly operates in the blended mode. The electric motor and IC engine complements each other such a way that the fuel economy is maximum. A PHEV requires a higher battery bank compared to a full hybrid, and it can also be charged using charging ports. On the other hand, an REV or range extended vehicle is derived from a battery electric vehicle. So, it mostly operates in pure electric mode with electric motor alone as propulsion device. So, it operates in pure electric mode until a threshold of battery pack voltage is reached, where it starts the smaller rated IC engine to charge the battery to support the electric mode. A full hybrid HEVs can be further classified into 4 types: series hybrid, parallel hybrid, series parallel hybrid, and a complex hybrid. So, let us see the configurations of few of them. So, this is the configuration of a typical series hybrid electric vehicle, where an IC engine is connected to a typical electric drive using a electric generator and a battery charger. So, this configuration allows high efficiency operation of IC engine. This is the configuration of a conventional parallel HEV, where both the IC engine and battery based electric drive is coupled to the transmission system using a clutch known as dual clutch transmission or DCT. So, this system offers 3 modes: an IC engine mode alone, a electric motor mode alone, or a combined IC engine and electric motor mode. So, the electric motor can not only be used to operate the vehicle, it can also be used to recharge the battery during regenerative braking. This motor can also be used as generator to recharge the battery when the power required at the wheels is less than the power available from the IC engine. This is the configuration of a typical series parallel HEV, which combines both the features of a series hybrid and a parallel hybrid. Such a configuration is possible only because of a special gearing system, which is known as continuously variable transmission system or CVT, which allows all the modes of a series hybrid and parallel hybrid together. So, what are the challenges of a typical battery electric vehicle? The energy storage capacity of a battery electric vehicle is lower compared to a IC engine based vehicle because of low specific energy and low energy density of battery compared to a liquid fuel. Therefore, it offers a limited driving range. For similar conditions, it is around 120 km per charge for a BEV compared to around 500 km per charge for a IC engine based vehicle. PHEV suffers from the problem of range anxiety among customers. So, what is done is more battery banks are used to match the operation of IC engine based vehicles. Therefore, it is not only oversized, it is very costly. Also, since the battery have a limited cycle life of around 1500, which means 4 to 5 years, it requires replacement of battery bank in around 5 years, which again increases the cost of battery electric vehicle. The battery electric vehicle also faces the challenge of lack of charging infrastructure compared to a IC engine based vehicles. Charging requirements of a BEV lead to discontinuous operation of the vehicle. In normal charging, it takes around 5 to 8 hours for a typical 110 to 40 volt, 13 to 40 amperes and 2 to 4 kilowatt system. But it can be reduced to less than half an hour if we use a system which is 200 to 400 volt, 100 to 200 amps and 50 kilowatt system, which is also known as fast charging. These systems put a lot of pressure on the power grid, since it is drawing very high currents from the utility grid, and it requires a costly charging infrastructure. One of the solutions noted is battery swapping technique, where the battery bank will be mechanically replaced at a battery swapping station, but this solution requires standardization of battery packs and sizes. A conventional HEV suffers from non-zero emissions, low energy diversification, as we know that it can be only refueled using oil and natural gas. The system is very complex and it requires lot of coordination to achieve fuel economy. It requires a device called variable transmission system, which has its own losses. It creates a lot of noise and it requires regular lubrication. The system is quite heavy and also bulky. Gradable HEV faces all the challenges faced by a conventional HEV that we have seen. It is more costly since it requires more battery capacity. In some vehicles, it requires installation of onboard chargers also. A fuel cell electric vehicle requires a very high initial cost. Since the cost of fuel cell is very high, it also suffers from a lack of hydrogen refueling infrastructure, since it is not commonly available. The storage of hydrogen is very challenging. There are three ways in which hydrogen can be stored. One is method similar to CNG, which is compressed hydrogen gas. Second is liquid hydrogen. It requires technology similar to cryogenic storage technology, which is also costly. It can also be stored in a solid form as metal hydrides. So, this system is very similar to battery swapping. A hydrogen based vehicle has high safety concerns of explosion, and therefore, it requires lot of safety factors to be in place before it can be commercially viable. Ultra capacitor and ultra flywheel based system are upcoming. The challenges they are facing are, it is very costly, it has low specific energy, therefore, it cannot be used as a sole energy source and it requires battery as a hybrid energy source along with it. In addition, ultra flywheel, which stores mechanical energy at high speed of flywheels, often have safety concern and is less reliable. So, this is the end of session of our topic overview of types of EVs, and we will start discussion on our next topic, which is motor drive technologies used in a EV in our next interaction. So, thank you for listening.